Hi everyone. Just as a quick reminder, the day 2 homework worksheet is due tomorrow in class. For now, we are just filling out this worksheet. There's no homework to go along with this, but there is a Do Now quiz tomorrow based on this video. And as we go along the video, I will let you know exactly what's going to be on that quiz. So as long as we pay attention to this, we will do great. Anyway, what I want you to do is to put these equations in your calculator and sketch them. I really suggest that you pause the video. That way you could see them on your own. Unfortunately, my calculator on this computer is not working. So if you were to graph these, you would see something that looks like this. There we go. So we have two graphs that are going up, and we have two graphs that, or just one graph that is going down. So the question is, what's the difference between the first two graphs and the third graph that determines if one goes up versus one goes down? Now, the difference is that the base in the first two is a 2, and the base in the third one is a half, or 0.5. So that actually determines whether you are going to go up or down. Because your base is greater than 1, the equation goes up. Or rather, I should say, the function increases. So if the number attached to the exponent is greater than 1, you go up. If your base is less than 1, then the function decreases and goes down. Technically, it's greater than 1, less than 1, but also greater than 0. So we're going to look at our base to see if our exponential functions are increasing or decreasing. And what's important about that is that I said exponential functions. In order for it to be an exponential function, the variable has to be an exponent. Now we have the difference between 1 and 2, because 1 is 2 to the x, the other is 5 times 2 to the x. So if you take a look at the table, for all three of them actually. Okay. Looked at the graph for all of them, and I made a table for us. Now, if you see what all of these graphs have in common, we have our starting point. For the first and the second one are the same. So we have that this coordinate right here is 0, 1. And this coordinate right here is 0, 1 as well. However, this one has 0, 5 as our initial value. Initial is your starting point. And the question is, what gives us that difference between 0, 1 and 0, 5? What that difference is if you notice, this guy has a leading coefficient of 5. So it gives us an initial value of 5. This one has a leading coefficient of 1. This is really 1 times 2 to the x. And this one is a leading coefficient of 1 as well. So that tells us what we're going to be starting with, our initial value. The reason for that is if you have 2 to the 0, anything to the 0 power is 1. But if you have a leading coefficient in front, it's going to multiply that 1 in the middle case to be 5. So we look at our base to figure out if we're going up or down, increasing or decreasing, but we look at the leading coefficient to know what our initial value is, that y-intercept. All right, I think I've talked about everything I need to talk about here. Let's take some notes about it though. We have exponential growth versus exponential decay. So growth is increasing, decay is decreasing. Actually, I want to go back and I want to talk about one other thing. Do you notice how here you are multiplying by 2? You are multiplying by 2. You are multiplying by 2. You are doubling. And the reason you're doubling is your base. So exponential functions have this pattern of multiplication. Here, because your base is 2, you are multiplying by 2 each and every time. Whereas here, your base is a half, so you are going to be dividing by 2. Or really, forget about dividing by 2, you're multiplying by 1/2. And next week, we're going to get into word problems with half-life and doubling. So when you have a half-life, your base is 1/2. When you are doubling, your base is 2. If you were tripling, your base would be 3. Now I'm on to the next part. How do you get rid of this? Really? There we go. So for our graph, we have exponential growth. And we have exponential decay. And in general, if you don't have a number in front, you will have the coordinate 0, 1, as long as there's no leading coefficient. Anyway, if you have y equals b to the x, your growth, if your b is greater than 1, your decay, if your b, your base, is less than or equal, I don't want to say less than or equal to 1, sorry, as long as your base is between 0 and 1. If you're equal to 1, then that doesn't actually do anything. So the way we're going to see this today in word problems is we're going to have a equals p times 1 plus or minus r to the t. Now I'm going to explain what that means in a bit. Your r is your rate. So we're going to be dealing with word problems where we're increasing by like 20% or decreasing by 30%. So we say that if you're increasing, you have 1 plus your percentage, your rate, or if you're decreasing, it's a 1 minus r. That might seem a little weird right now, but I swear it will make sense in a bit. So for example, if you see y equals 1.2 to the t power. This is increasing because it is greater than 1. And how much is it increasing by? We would say that this is 1 plus 0.2. So the 0.2 is your rate. You're increasing by 20%. Now, if you had y equals 0.8 to the t, this is decreasing because your base is less than 1. How much are you decreasing by? This is 1 minus 0.2. So you're decreasing by 20%. We're going to go into it more. But what we do need to know is A is your initial value. Your B is the growth or decay factor. X is your time, or usually T is going to be your time in years. R is your growth decay rate. And P is called your principal value or your initial value. It's just that in word problems, sometimes they call it the principal amount. A is your future amount. So P is your initial, whereas A is how much money you're going to have in the future. Typically, we're going to be talking about money. Just please be careful between the word growth factor. Your growth factor is the entire base, whereas the rate is just the value of R. So let's try a few examples because this is probably a bit confusing right now. For the first one, we have 3 times 1.7 to the x. This is exponential because your exponent is x. Your initial value is your coefficient. And the coefficient is 3. So on a coordinate, you would see this as 0, 3. In order to know if it's growth or decay, you're going to look at the base. In this case, your base is greater than 1. So, I mean, obviously 1.7 is greater than 1, so we are going to say that this is growth. So the type of function that we're looking at right now is something like this. You are going upwards, and this right here is going to be 0.3, your initial value. Now, the growth factor is just your base. Your growth factor is 1.7. However, the growth rate is the percentage that you're increasing by. So because it's growth, you have 1 plus r. This is equal to 1.7. Your goal is to solve for what r is. So you end up with r equals 0.7. That means in a word problem, you'll see this as increasing by 70%. So it's important to know that the factor is 1.7, but the rate is 0.7 that represents 70%. Try in the next one. This next one has an initial value, which is your coefficient, of 1. On a graph, that would be 0.1. Looks like point. There we go. This is going to be a decay function because 0.8 is less than 1. So that means if we were to look at this graph, it would look like it's going downwards. And this point right here would be the coordinate 0.1. The factor is the entire base. So the factor is 0.8. The rate is just r. Now, because you're decreasing, this is a 1 minus the rate equation. So 1 minus the rate gives you 0.8. Now, you can think about this in your head if you wanted to. You don't have to write the equation. You could think if you started at 1 and you went to 0.8, how much did you go down by? You went down by 0.2. Or you could solve the equation. You would subtract 1 on both sides, and you get negative r equals negative 0.2. So positive r equals positive 0.2. This is decreasing by 20%. Let's try the next one. Your initial value is still has a 1. So the coefficient is 1, so the coordinate of the initial value is 0.1. This is a decay function because 1/4 is less than 1. So this function is going downwards. The growth factor is 1/4, or if you would like, 0.25. The rate, usually we don't write the rate as a fraction. We usually express the rate as a decimal, but I guess that's up to you what you would like to do. You would set this up as a 1 minus r, and 1 minus r is equal to 0.25. Now you can think of it this way. If you started at 1 and you went down to 0.25, how much did you lose? Well, I lost 0.75, right? 75%. Or you can solve the equation. If you solve the equation, you get negative r equals negative 0.75. So positive r equals 0.75. This is decreasing by 75%. So the growth factor tells you how much, or rather the growth factor tells you if you're increasing or decreasing, whereas the rate tells you how much you're increasing or decreasing by. It's more specific. Let's try the Regents question. In the equation, y equals 0.5 times 1.21 to the x. Y represents the number of snowboarders in millions, and x represents the number of years since 1988. Identify the initial value and the growth factor or rate and explain what it means in context of the problem. Now, this is very important. It said the factor or the rate. It's giving you a choice. A lot of Regents problems, they actually specify whether you need the factor or the rate. So the distinction between the two vocabulary terms is very important. I really think you should try this problem on your own. You should pause the video, write your answer, and come back to it. Whether you actually do that or not, hey, I'm going to go with probably not. Okay, we have that the initial value is your coefficient. Now, your coefficient is 0.5. We're talking about context of the problem, so you have to mention what's actually happening. So you have to be specific. You can't just say the initial value is 0.5. That's not talking about the snowboarders. We're talking about how many snowboarders we have to begin with. Now, 0.5 snowboarders doesn't really make sense. You can't have half of a person. And if you read the problem carefully, it says the number of snowboarders in millions. So it doesn't represent 0.5 snowboarders. It represents 500,000 snowboarders. Now, you can either write 0.5 million, or you can say half of 1 million is 500,000 snowboarders. Oh, that's not how you write 500,000. Okay, that's your first part. The next part says to identify the growth factor or rate. So the growth factor is the base. So the base here is 1.21. The rate is r. Now, if this is a 1 plus r equation, r is going to be the 0.21. Now, you could put whichever one that you wanted to, but it represents that the snowboarders increased, right? Because it is greater than 1. If your factor is greater than 1, the base is greater than 1, that means you increase. How much did you increase by? Well, you increased by 21% each year since 1988. So this was a 2-point question. You got 1 point for each one. And if you didn't notice that if this was in millions, you only got 1 point, unfortunately. Try the next one. The current population of a town is 10,000. This is your initial. If the population increases by 20% each year, which equation could be used to find the population after t years? Now, the easiest way to do these problems is that if you are increasing, your base is greater than 1. So go through the whole problem and cross out the ones that don't have a base greater than 1. Both of these have a base less than 1. So these are decreasing, whereas these two are increasing because their base is greater than 1. Now, if you don't know that, put them in the calculator, look at the graph. Choice 3 and 4 in the graph go upwards. Now, you want to specifically increase by 20%. Because you're increasing, you have a 1 plus r equation. We have your rate is not 20%. Our rate is 0.2. So it's really important to notice that we never put percentages in equations. We always use the decimal form. So we have 1 plus 0.2 is going to be 1.20. That is going to be choice 3. Whereas this one, the rate is equal to 0.8. That one's increasing by 80% each year. Okay, we're all good. The next one, a car depreciates. That means you're losing value at a rate of 4.5% annually. Greg purchased a car for $12,500. Which equation can be used to determine the value of the car after 5 years? Well, this is your initial. Your initial value is your coefficient. And because you're decreasing, your base is less than 1, also greater than 0. This is a 1 minus r equation. I'll get back to that in a bit. The 5 years is your t. It's the value of your time. So because you're decreasing, go through each question and see which one has a base less than 1. We're crossing out 2 and 4 because the base is greater than 1. These are both increasing. So the question is it choice 1 or is it choice 3? Now, because you're decreasing, this is a 1 minus r equation. The question is, what is r? R is a decimal, so this is going to be 0.045. What you have to do is percentages are out of 100. 100 has 2 zeros. So you always got to move the decimal over 2 spaces. That would give you 0.045. Anyway, we have 1 minus 0.045. If you were to subtract, you would get 0.955 to be choice 3. Now, the 0.955 is your factor, whereas the 0.045 is your rate. And I know you're decreasing. It's still called a growth factor. Sometimes you could see it as a decay factor, but we don't, sometimes they just specify as growth factor, even though you are really decaying. It's a little weird how they have that terminology. For number 4, you have Audra, whatever, is interested in studying the number of students entering kindergarten in Alville, I don't know, whatever, Central School District over the next several years. Using data backing to 2015, she determines the number of kindergartners is decreasing at an exponential rate. That means your base is less than 1 and greater than 0. She creates a formula to model the situation a times b to the x, where x is the number of years since 2015 and y is the number of students entering kindergarten. If there were 105 students in Asheville in 2015, which statement about the girls' formula is true? So 105 is your initial. Your initial is your coefficient. So I don't know how much we're increasing or decreasing by, but I do know that this is y equals 105 times b to the x, where b is less than 1, greater than 0, because you are decreasing. So first of all, my A is positive because 105 is positive. So we can cross out choice 2, and we can cross out choice 4 because you want A to be positive. Now, your base is between 0 and 1. That means B is positive because you have to be greater than 0. So even though you're less than 1, B is still positive. Okay, number 5. The populations of 2 small towns beginning with 2018 and their annual population growth rate are shown in the table below. Now, because it's your growth rate, this is R. It's not your factor. For each town, write an equation to model its population. So, really important, this one is like the quiz tomorrow. So this is where we should be paying attention because I'm going to give you a word problem tomorrow, and you're going to have to write the equation. So for each town, model the population. We are going to have y equals a times b to the t. Or because you have growth, this is going to be y equals a times 1 plus r to the t power. So we have j and we have w. So j of t, just like f of x, or you could just have j equals how much you are starting with. This is your initial, which means it should be your coefficient. So our initial is 1,275. This is going to be a 1 plus r problem. Here, your r is equal to 0.08. If you don't know that, you're going to do 8 divided by 100. 100 because percentages are out of 100, and that is 0.08. So this problem is 1 plus 0.08 to the t. If you would like, you could write this as 1,275, your initial value, times 1.08 to the t. Your base is greater than 1, so you know that you're increasing. The next one, Williamstown. You have w of t equals how much you're starting with. We are starting with 850. Now you're increasing by how much? You're increasing by 0.13, 13%, or 13 divided by 100 is 0.13. So we have 1 plus 0.13 to the t. Or you can rewrite this as w of t equals 1,000, I was copying the other problem, 850 times 1.13 to the t. And that's it. You have to know whether you're 1 plus r or you're 1 minus r. I want to do one more. Let's say we have Valley Stream. And let's say Valley Stream started with, you know what, let's not go with Valley, whatever. We're making up numbers. And let's say we started with 2,013 people. Whether we have more or less, I have no idea. But let's say we decreased by, let's go with 7%. You would say V of T for Valley Stream started with 2,013 people, but because you're decreasing, this is a 1 minus R. So you would have 1 minus 0.07 because R is 0.07 to the T. And that means if you wanted to simplify it, you have 2013 times 1. Oh, if you did 1 minus 0.07, that would be 0.93 to the t. So your base is less than 1, which means you are decreasing. That's going to be your quiz tomorrow. You're going to be given an initial, and you're going to be given a rate, and I want you to write the equation, whether you're increasing or you're decreasing. Your factor is the base, the 0.93, but your rate is the 0.07 that you're decreasing by 7%. All right, now for a challenge problem, in what year will the two populations have the same population? Now, it's a multiple, okay, no, it's not a multiple choice question. On the regions, it actually was a multiple choice question. So to have the same population, that means they are equal. And you want in what year, you're figuring out the value of t. So we have 1,275 times 1.08 to the t equals 850 times 1.13 to the t. What you're going to do is put this in the calculator in y1. You're going to put this in the calculator in y2. And you are going to do second trace intersect. Now, instead of t, you're going to put x in your calculator. And unfortunately, I told you earlier, my calculator ain't working. Oh, so can you actually try to graph it? That way you can make sure you can do this as well. So if you were to put these in the calculator, the thing is you wouldn't see anything. And the reason you wouldn't see anything is because your initials are too high to see anything. So what you're going to do is you're going to hit Window, and if you want to see higher, you have to change your y value. If you want to see higher, you got to change your y max. Now, if your initial is 1,275, you should make your y maximum larger than that. And you can really play with whatever you want. In this case, I'm going to make my y max 5,000. Then graph. Now, if you were to graph it, you would see something that looks like something like that-ish. And where they intersect is when the populations are equal. So now you would do second trace intersect. And I really think you should be following along with this on your calculator to make sure you can do it. You're going to scroll to where you think the point is. And once you get to the point and you scroll over far enough, you're going to hit enter 3 times. You should be getting that the intersection is 8.9592 498. Your y value is 2,540.7501. Now, this problem was done in terms of t's, so maybe you might want to make this a t instead of an x. But my point is, how long will it take them? It will take them about 8.96 years. And how many people are they going to have? They're going to have about 2,541 people. Can't have half of a person. So I'm going to round up to 41 people. Okie dokie. Let's see. Okay, the very last one. The breakdown of a sample of a chemical compound is represented by the function that, where P represents the number of substances, the milligrams of the substance, and T represents the time in years. In the function, explain what 0.5 and 300 represent in context of the problem. All right. The context of the problem means you need the words. What's happening? We're talking about the breakdown of the chemical compound. So it's how much of the chemical compound do you have? So the 300 is your initial. Let's pretend I actually spelled initial properly. That means we started with 300 milligrams of the compound. What does the 0.5 represent? Well, the 0.5 means that you are decreasing. How much are you decreasing by? You're decreasing by 50%, because if you have 1 minus r equals 0.5, and if you solve for 1, you get that r is equal to 0.5. So this is the case where the factor and the rate are the same value. So it means that you are decreasing by, or you are losing 50% of the compound each year. And it's important to note that it's 50%, it's not 50 milligrams. If you have exponential functions, it's always percentage-wise. Okay, I lied. We had 2 more problems, and then I'll officially be done. These are Regents questions, so they are really important. The depreciation, the decline in cash value on a car, can be determined by that formula, where V is the value of the car after T years, C is the original cost, that means it's your initial, and R is the rate of depreciation. If a car's cost is $15,000 and the rate of depreciation is 30%, the value of the car is now 3,000. How old is the car to nearest tenth of a year? All right, because you have decay, let's write the formula down. Your initial is 15,000. Because your decay, your R is 0.3, and you're going to do 1 minus 0.3. Now this part is on your quiz tomorrow, being able to write the formula. Now they're telling you that eventually it's going to be 3,000. This is your future amount, and that's what you're equal to. So this is equal to 3,000. They want you to solve for t, which we have done before. We have 3,000 equals 15,000, and it makes sense that the future is 3,000 because you're decreasing, so you should be less than 15. 1 minus 0.3 is 0.7. If you want to solve, you need to get the base by itself first. So you would divide both sides by 15,000. And in your calculator, this would just be 1/5. If you want to solve, we know how to switch this to a logarithm. So you would keep the base. The base is on the right, so you would write log base 0.7 on the right and switch the other 2 values. That means 1/5 goes to the right, and the t on the right goes to the left. You would put this in the calculator using alpha, window, choice 5. This would be log base. And let's see, we have alpha, window, choice 5, log base. We have log base 0.7 of 1/2. You would get in the calculator 1.9433581. So to the nearest tenth of a year, I lied because I didn't plug it in properly. I did 1/2 instead of 1/5. The nearest tenth of a year would be 4.5 years. Last one, promise. Currently, the population of the metropolitan Waterville area is 62,700. It is increasing, so this is a 1 plus r equation at an annual rate of 3.2 0.025%, that means your rate is really 0.0325 as a decimal. The situation can be modeled by that equation, where this was, remember, 1 plus 0.0325 because it was a 1 plus r equation. P of t represents the total population, t represents the number of years from now. Find the population to the nearest 100 7 years from now. So they're telling you 7 years from now is t equals 7. So all you have to do is take the formula and write 62,700 times 1.0325 and put in 7. They want you to figure out what's the population. So we're putting it in our calculator. And if you put it in your calculator, you got 78432.84403. Now they didn't ask the nearest hundredth, they asked the nearest hundred, as in how many hundreds of people. So the nearest hundred would round down to 400. That means you had 78,400 people. Whereas hundredth would be 78,432.84. So please pay attention to hundred versus hundredth. And part B, determine how many years to the nearest tenth it will take for the population. So we have how many years, t, to reach 100,000. This is your P of t, a future amount. So you have this on the regions would probably be 4 points, by the way. 2 for the first one, 1, you lost a point if you rounded wrong, and 2 for solving. Or possibly 1 and 3, I don't remember at the moment. You have 100,000 equals 6,200 and 700. Okay, you're solving for t. And notice that because you're increasing, you're going from 62,000 up to 100,000. Your first step is going to be divide by the coefficient, always. And that doesn't even give you a point on the regions because they expect that part to be easy. So in your calculator, 100,000 over 62,700 simplifies to 1,000. Let me write this in a different color. I don't suggest doing this as a decimal. You should really leave it as a fraction. It becomes easier for you. Equals 1.0325 to the t. You have an exponential equation. You could solve this with logarithms. So you're going to take your base. Your base is on the right? Log base 1.0325 on the right. You're going to switch the other two values. The t comes to the right. The 1,000 over 627 goes to the right. You put this in the calculator. Alpha, window, choice 5, you have log base 1.0325 of alpha y equals 1,000 over 627. Your calculator tells you this is 4.59550602. They asked you to round to the nearest tenth. So if you round to the nearest tenth, that would be rounding up to 0.6. Okay, officially done. Sorry it took so long, but that is it. I hope you have a good rest of your day and see you tomorrow.